Hello students, so welcome to the second lecture on the classification of curves based on the general second degree equation. So we know that the equation of a parabola or ellipse or hyperbola or a pair of straight lines or circle, all these equations are second degree equations in x and y. You can see that the equation of a parabola is of this type, y square is equal to 4ax. The equation of the circle is of this type, x square plus y square is equal to a square. The equation of a pair of straight lines is of this form, alright, of this type, right? And the equation of a ellipse. All these equations are similarly equation of hyperbola. All these equations are second degree equations in x and y. So the equation of a conic section is always a second degree equation in x and y. Now today we will discuss the converse part of this. Today we will show that every second degree equation, every general second degree equation always represents a conic section. So what is a general second degree equation? A general second degree equation is of this type: ax squared plus 2hxy plus by squared plus 2gx plus 2hy plus c equal to 0. This equation, this is a general second degree equation in x and y. We shall show that a general second degree equation, a general equation of second degree always represents a conic section. A general second degree equation always represents a conic section. This we will show today. So how do we show that? Suppose we have a general second degree equation in x and y where a, h, b, g, f, c are all constants. So what we do is we rotate the axis by an angle theta by putting x is equal to x cos theta minus y sin theta and replacing y by x sin theta plus y cos theta. We rotate the axis. We have already discussed how to rotate the axis. When you rotate the axis, the relation between old coordinates and new coordinates is given by this relation: cos theta minus sin theta, sin theta cos theta. So this into this, x cos theta minus y sin theta is equal to x, and x sin theta plus y cos theta is equal to y. So this is how when the axes are rotated, then the x is replaced by this expression and y is replaced by this expression when the axis is rotated in the anti-clockwise direction by an angle theta. So if you replace x by this symbol and y by this symbol, that means we have rotated the coordinate axis by an angle theta in the anti-clockwise direction. Then this equation will become this: x cos theta minus y sin theta square plus 2h x cos theta minus y sin theta x sin theta plus y cos theta. This is 2hxy plus by square. This would be x sin theta plus y cos theta plus by square plus 2gx x cos theta minus y sin theta plus 2gx plus 2fy 2gx plus 2fy x sin theta plus y cos theta plus c equal to 0. So when we have rotated the axis by an angle theta, this equation becomes this when we replace x by this and y by this. So if you collect the, if you rewrite this equation, it would be of this type: x square into a cos square theta plus 2h cos theta sin theta plus b sin square theta plus 2xy h into cos square theta minus sin square theta minus a minus b cos theta sin theta plus y square to a sin square theta minus 2h cos theta sin theta plus a plus b cos square theta plus we have the coefficient of x. The coefficient of x would come out from here plus 2x. This would be equal to g cos theta plus f sin theta and plus 2y, and the coefficient of y would be equal to f cos theta minus g sin theta plus c equal to 0. Right? So first of all, we have this general second degree equation. We want to show that this general second degree equation always represents a conic section. This always represents a conic section. So what we have done is we have rotated the axis in the anticlockwise direction by an angle theta, and that means replace x by this symbol and y by this expression. This is the transformation. Then this equation gets transformed to this equation, and this equation can be rewritten in this form. And now what we will rotate the axis in such a way such that the xy term in this equation becomes 0. We will find this angle theta, the angle by which the axis is to be rotated, so that the xy term in this equation becomes 0. So to find that value of theta, we put the coefficient of xy equal to 0. If you put to eliminate xy term, put this coefficient of xy equal to 0, h. So this is 2h cos square theta minus sin square theta minus a minus b cos theta sin theta is equal to 0, and this gives you 2h cos square theta minus sin square theta is equal to 2a minus b cos theta sin theta. Now this 2 into cos theta into sin theta is sin 2 theta, and this is cos 2 theta. So this is equal to 2h cos 2 theta is equal to a minus b sin 2 theta, and that gives you tan 2 theta is equal to 2h over a minus b. So to first of all, we have a general second degree equation. Alright, then we transform the axis by an angle theta in the anticlockwise direction. For that, we have to replace x by this expression and y by this expression. Then this equation gets reduced to this equation, and this equation can be rewritten like this. and what we want to do is now is we want to find the angle of rotation so that the xy terms gets eliminated. So to eliminate the xy term, we put the coefficient of xy term equal to 0. So if you put the coefficient of xy term equal to 0, you get tan 2 theta is equal to 2h over a minus b. That means if you find such an angle theta for which tan 2 theta is equal to this, then, and if you put that value of theta in this equation, then the xy term would be 0. Xy term would get eliminated. So we can find theta lying between minus pi by 4 and pi by 4 if a is not equal to b. If a is not equal to b, then you can always find such a theta for which tan 2 theta is equal to this, because tan takes all real values, alright, between minus pi by 2 and pi by 2. So we can find such a theta lying between minus pi by 4 to pi by 4 if a is not equal to b, and if a is equal to b. If a is equal to b, this becomes tan 2 theta becomes infinity, and that means tan 2 theta is equal to pi by 2, and that means theta is pi by 4. Then theta is equal to pi by 4. So if a is equal to b, in this equation, then by putting theta is equal to pi by 4, the xy term in this equation would get eliminated. And if a is not equal to b, then also you can find a theta from this equation. That theta will lie between these two angles, minus pi by 4 to pi by 4, such that the xy term gets eliminated. So we can definitely eliminate the xy term from this equation, and this equation would finally reduce to so xy term gets eliminated. So when xy term is eliminated, we write this as capital A and this as capital B. So this equation becomes of this type: ax square plus by square plus 2gx plus 2fy plus c equal to 0. Xy term is eliminated. So if you find theta such that tan 2 theta is equal to 2h over a minus b, this kind of theta we can always find. So if you find such a theta, then and put that value of theta in this equation, then the xy term would get eliminated, and this equation will become this type of equation: some constant into x square plus some constant into y square plus coefficient of x and coefficient of y plus 2gx plus 2y plus c equal to 0. This equation will become this. So this general second degree equation can be reduced to an equation of this type. This general second degree equation can be reduced to an equation of this type by rotating the axis by an angle theta in the anti-clockwise direction. Right? So by rotating the axis, you can reduce this general second degree equation to an equation of this type. Now we will discuss some cases for this equation, what this equation will represent under various cases. So we will show that this equation will represent either a parabola or ellipse or a hyperbola or a pair of straight lines or a circle under different conditions, and that means we will show that this equation always represent a conic section. That we will do. So you can have a look on this, and then we will proceed further. So students, what we are doing is we are trying to show that a general second degree equation always represents a conic. A general second degree equation in x and y will always represent a conic section. So how we have started is, suppose this is a general second degree equation, ax square plus 2hxy plus by square plus 2gx plus 12y plus c equal to 0, and we will show that this equation always represents a conic. So how do we go about it? We rotate the axis in the anti-clockwise direction by an angle theta, and when we rotate the axis by an angle theta, x gets replaced by this expression and y gets replaced by this expression. This we have already discussed. So when x is replaced by this and y is replaced by this equation can be reduced to this equation, this type of equation, if we take theta to be like this. If you find theta from this equation, tan 2 theta is equal to 2h over a minus b. So if you find theta from this equation, then putting that value of theta in these transformations, and we can reduce this equation to this type of equation. And what is the speciality of this equation? There is no xy term. There is no xy term here. So we can remove xy term from this equation by taking these transformations. And this is very much possible, that we have already discussed. So now, once we have reduced this equation to this equation, we will discuss various cases. So, and each case will tell us that this equation is the equation of a conic. So what we have got now, we have got this equation now, ax squared plus by square plus 2gx plus 2fy plus c equal to 0. We have got this equation. So we did discuss the following cases. Case number 1. Case number 1 is, suppose a is not equal to 0 and b is also not equal to 0. If a is not equal to 0 and b is not equal to 0, this equation can be written like this: ax squared plus 2g over x plus by square plus 2f over b y plus c equal to 0, and this can further be written as, by completing the square, x square plus 2g over ax plus g square over a square plus b into y square plus 2f over b y plus f square plus b square, and this c can be written to the other side. And we have introduced some extra terms here, g square over a square. So multiplied by a, this is g square over a. To balance, you write g square over a here, and here you write f square over b, and minus this minus c. So this equation can be written like this, and this is a complete square. So this is a into x plus g over a whole square plus b into y plus f over b whole square is equal to this expression. This expression we can write as a. This expression we can write as a. So we have this equation, and if we shift the origin to minus g over a, shifting the origin, to minus g over a minus f over b, okay, by replacing x by x minus g over a and y by y minus f over b. This equation gets reduced to ax square plus by square is equal to. This equation gets reduced to this equation. And now we have the further sub cases. Sub case 1, if k is equal to 0, if k is equal to 0, then this equation becomes of this type: ax square plus by square is equal to 0, and that implies y square is equal to minus a over b x square. And this is the equation of a pair of straight lines. This is which represents a pair of straight lines. Alright, pair of real straight lines if a over b is negative, and pair of imaginary straight lines if a over b is positive. So this equation represents a pair of straight lines, and a pair of straight lines is a conic section. A pair of straight lines is a conic section. We have already discussed. And the second subcase is subcase 2. If k is not equal to 0, if k is not equal to 0, then this equation can be written as x square over k over a plus y square over k over b is equal to 1. If k is not equal to 0, this equation can be written like this. And this we have the further sub cases which represents this equation represents an ellipse, if k over a and k over b are of the same sign. If k over a and k over b are of the same sign, then this is the equation of an ellipse, and this is the equation of a hyperbola. If they are of opposite sign, same sign, and both are positive, okay, both should be positive, then it represents an ellipse. And if they are opposite sign, if k over a and k over b are of opposite sign, one positive and one negative, then this equation represents a hyperbola. And if a is equal to minus b, this represents a rectangular hyperbola. If a is equal to minus b, then this is the equation of a rectangular hyperbola. And if a is equal to b, then this is the equation of a circle. This represents a circle. If a is equal to b, and if a and b are of the same sign and both are negative, then this represents a imaginary ellipse. If a and b, if k over a and k over b are of the same sign but both are negative, then this represents an imaginary ellipse. So you will see that in all these cases, whether k over a or k over b are of the same sign or opposite sign or all other cases, this equation always represents a conic section. It represents an ellipse or hyperbola or rectangular hyperbola or a circle. So in this main case, when a is not equal to 0 and b is not equal to 0, we have discussed that this equation always represents a conic section. Now the second case, case 2. Case 2 is when a is 0 and b is not equal to 0. A is 0 and b is not equal to 0. When a is 0 and b is not equal to 0, in that case, this equation becomes this type of equation: by square plus 2gx plus 2fy plus c equal to 0. Here we will discuss the subcase 1. If g is not equal to 0 and if g is equal to 0. We will discuss two sub cases here. If g is not equal to 0 and if g is equal to 0. If g is not equal to 0, then this equation can be written as b y square plus 2x over b y plus 2g over b. Okay, we are dividing by b everywhere. So this is equal to y square plus 2f over b plus 2g over bx plus c over b is equal to 0. And if you complete this square, then this equation becomes y square plus 2f over b y plus f square over b square is equal to, you can introduce you will write it like this, 2gx, so 2g over bx plus c over b minus f square over b square equal to 0. And this equation further can be written as this is a whole square, y plus f over b whole square plus, you take this as common, 2g over b, 2g over b if you take as common, this is x plus b over 2g, this will be c over 2g and minus f over 2bg equal to 0. Alright, and if you shift the origin, now shifting the origin to minus of this sign, minus of this expression, this is minus c over 2g plus f square over 2bg, and minus of this is minus f over b. Shifting the origin to this point, this equation can be written as, that means replace x by x minus c over 2g plus f square over 2bg and y by y minus f over b. This equation will reduce of this equation, y square plus 2g over b x is equal to 0. Alright, or y square is equal to minus 2g over b x. So this equation gets reduced to this equation, and this equation you can see represents a parabola. This equation represents a parabola. Y square is equal to 4ax type equation. So this equation represents a parabola in the case when g is not equal to 0. And the case when this g is equal to 0, second sub case is when g is equal to 0. So I hope you are following. So if g is equal to 0, sub case 2, we are discussing the main case 2 when a is equal to 0 and b is non-zero. So sub case 1 is if g is non-zero, then this equation can be written like this, and this is the equation of a parabola. Again we have got a conic section. And if g is equal to 0, sub case 2, if g is equal to 0, then this equation would become by square plus 2fy plus c equal to 0, and y would be equal to minus b plus minus b square minus 4ac divided by 2b. Then you can find if g is equal to 0, this equation will become this equation, and from here you can find y like this, and this equation represents a a pair of straight lines by taking plus sign here, and once you take plus sign and next time you take negative sign. So this is the equation of a which represents a pair of straight lines, represents a pair of straight lines. If f square minus bc is positive, then this is a real pair of straight lines, parallel lines, right? Pair of straight lines parallel. If f square minus bc is positive, then this is a real parallel lines. This represents a real parallel line. If f square minus bc is negative, then you have imaginary pair of parallel lines. And if f square minus bc is 0, then you have two coincident lines. A pair of lines, coincident lines. So, and all these lines, pair of parallel lines, pair of straight lines, coincident lines, they are all conics. So, in this case also, case 2 also, we have discussed that the equation will represent a conic section. Third case is case 3. Case 3 is when A is non-zero and B is zero. If A is non-zero and B is non-zero, this case would be discussed similarly the case we have discussed when A is 0 and B is non-zero. The way we have discussed the case that A is 0 and B is non-zero, then also we get the equation of a conic section. Similarly, we can discuss the case case 3 when A is non-zero and B is 0. In that case can be discussed similarly. Again, we will have either a pair of parallel lines or a parabola. And case 4 is A is 0 and B is also 0. This is not possible. If A is also 0, if A and B are both 0, then you do not have a second degree equation. This is not a second degree equation. We are discussing about second degree equations. So this case is not possible. This case is not possible because if A and B are both 0, then this equation is no more a second degree equation. So in that case, that is not possible. And this case 3, it can be discussed. As case 2. Right? This case can be discussed in the same line as case 2. So in any case, we have observed that a second degree equation always represents a conic section, always represents either a parabola or ellipse or hyperbola or a pair of straight lines, parallel or intersecting vertical. So a second degree equation always represents a conic section that we have shown here. I hope you have understood, and you can refer to your books further to understand this more clearly. Thank you.